All right, welcome back to day 2 of notes. We are going to learn our last two exponent rules today. So these are the negative rule and the zero rule. So one of the things we have not dealt with yet is what to do with negative exponents. So our shorthand for this one is called cross the line, change the sign. Okay, that's going to be how we remember it, but let's talk about why we do it. Okay. A negative exponent is the opposite of multiplying. So we know that an exponent means repeated multiplication. So like for example, 3 squared. Hang on. So 3 squared really means 3 times 3, right? We're multiplying by 3 twice. So the opposite of that would be division. So 3 to the negative 2 power would really mean divide by 3 twice. So we're going to have that 3 times 3, but it's going to be on the bottom of the fraction. So it's going to be 1 over 9. Okay? So when we simplify, we just don't want to have any negative exponents. So we have to move any base that has a negative exponent from one side of the fraction bar to the other. So the same way we had 3 to the negative 2 power, we could rewrite that as 1 over 3 squared, right? That's equivalent to 1 over 9. Okay? So in other words, we're going to cross the line, change the sign. So here's an example of that. Here's some examples of a base that's a number and a base that is a variable, okay? So number bases moves just the same way as variables, but you might need to simplify them. So 3 to the negative 2, we already talked about, becomes 1 over 3 squared, which is 1 over 9. X to the negative 2 power would be 1 over x squared, and we can't simplify that any further. That just is what it is, okay? The other thing that we would have would be a negative exponent in the denominator, right? So it's already in the denominator. So it's going to move from the denominator to the numerator, cross the line, change the sign. So it's going to end up as y to the positive 5 exponent in the numerator. Okay, so if it's in the denominator and has a negative exponent, it just crosses the line to the numerator. Stuff in the numerator would go to the denominator. Okay. One of the last things we want to talk about is just that if we have a negative number, negative base, that's just a negative number, right? Negative 3 is going to just still be a negative 3 no matter where it is, okay? The q, however, q has this negative exponent. This is going to need to cross the line, change the sign. So q is going to move to the downstairs. So see how q to the third is now in the basement with a positive exponent, but the negative 3 is going to stay in the numerator, right? The exponent for that negative 3 is just a positive 1. It does not have a negative exponent. It's just a negative number, just the way we've always had negative numbers. They're fine. So let's do a little bit of practice with these. So what I do with these is if I don't have a fraction bar, I draw one right in, okay? So anything that we see that doesn't have a fraction is always in the top of a fraction, okay? We don't always see the denominator, and that's okay. So now we just have to identify our bases here. We have 2 and we have A. A has a negative exponent, right? It has that negative 2 exponent, so that one's going to have to move. So we just think cross the line, so it's going to go to the bottom, change the sign. So negative 2 is going to become positive 2. The 2 that was on the top of that fraction is going to stay there. So we're going to end up with 2 over a squared. So no negative exponents. We only have positive exponents. All right, let's do another example. This one, same thing, right? I have 5b to the negative third, but I also have b squared on the bottom. So similar to number 1, it's only the b with the negative 3 exponent that has to move, okay? So the 5 is going to stay up top, but now we have b to the third is going to move to the bottom, but we also have b squared down there. So this is where we're going to have to use one of our rules that we learned last time, which is the product rule. The product rule says if I have the same base being multiplied, I add the exponents. So b squared times b to the third becomes b to the 5th power. Okay, let's do some more examples here. So in this case, right, I'm going to kind of extend this line a little bit. I'm going to write 6 over 3, and then I'm going to write c squared and d to the negative 1, okay? So identify first, what do you have that has a negative exponent? It's only this, right? So this guy's going to have to move up here. But we also have 6 divided by 3. So think about just simplifying that fraction. Forget your exponents. It doesn't have anything to do with exponents. It's just going to become 2 over 1. And now we're going to rewrite. So we have 2c squared. And don't forget this d to the negative 1 moved up and got a positive 1 exponent. And then on the bottom, we just have a 1. But we don't really need to write this 1 on the bottom, and we don't need to write an exponent of 1. So I'm just going to rewrite this as 2c squared d. All right, that's all we need to do. All right, let's do our next one here. So again, this one does not have a fraction bar, so I'm just going to imagine everything here is sitting on top of this fraction. Okay, I see a couple of things that have negative exponents. So did you see e to the negative 9th and f to the negative 19th? But this negative 7 that's out front, that's not an exponent, so it can stay there. So let's move. Everything with a negative exponent is going to go to the basement, cross the line, change the sign, and I'm going to rewrite. There's going to be a lot of times to rewrite here, okay? All right, so we got negative 7. I'm going to put these in order. I'm going to do e to the 2nd, and then I'm going to do f to the 12th, right? And then the stuff that moved downstairs, e to the 9th, and then f to the 19th, right? So those should all be positive once we move them. And now I can see that I have e on the top, e on the bottom. I have f on the top, f on the bottom. So now I'm going to have to use my quotient rule. So again, we're going to subtract starting with the bottom. So I'm going to do 9 minus 2 and get rid of those. And 19 minus 12 and get rid of those. So I'm going to rewrite one more time here. So on the top of this fraction, I still have negative 7. And then line, I'm going to have e to the 7th, right? 9 minus 2. And then 19 minus 12 is also 7, so f to the 7th. Lucky sevens. There we go. Okay, we're going to move on to the next one. You can always pause and go back if you need to go back and review anything. Okay, our last rule is the 0 power rule, and we call it the easy one, but look how 1 is written, right? It's written as a number for a reason. So we call this the easy one because it's the super easiest rule. Anything to the power of 0 is 1. That's it. So here's my first example. And we're going to look at the difference between these two examples. So the first one is is in parentheses 2x raised to the 0 power. Well, anything raised to the 0 power is 1. So that one's easy. Okay, example 2 is a little bit different though, right? It's 2 times x to the 0. So the 0 power here is only applying to that x. So what I do is I just usually cross that out, right? So this is really 2 times 1, which is of course 2, right? So the x to the 0 is 1, but 2 times 1 is still 2. So these are a little bit different. But let's look at number 3. Right here I have a whole bunch of stuff in parentheses raised to the 0 power. It's 1. Okay. Here's an example that's a little bit busier, right? There's a whole lot of bases with a whole lot of exponents. The first thing I'm going to do is cross off any bases that have an exponent of 0. So I look 4 squared, x to the 3rd, y to the 0, cross it out. X to the 6th, y to the 7th, z to the 0, q to the 0. Just cross those out. Now this is looking a lot easier, right? We got 4 squared, which we can write as 16. We got x to the 3rd and x to the 6th, which we can write as x to the 9th. We can do a little bit of simplifying. All right, let's do a little bit of practicing here. So again, I want to go through and I want to say anything that has an exponent of 0, we can cross out. So I'm going to cross out z to the 0 right away. That's always going to be one of the first things you do because it's the easiest thing to do. And here, I'm going to maybe use my product rule first. So if I combine y to the third and y to the negative third, right? My product rule says add those exponents. Well, what do we get if we add 3 and negative 3? Well, we get 0, right? So that one's going to be y to the 0 power. And what happens when we have something to the 0 power? We cross it out. So my final answer would just be negative 2x squared. Example number 2 here, or practice problem number 2. We've got 81, x to the third, y to the 7th, z to the negative 24th, all in parentheses, all raised to the 0 power. So what is anything to the 0 power? 1. Done. All right, and then here we have those two examples that are very similar, but we have to know the difference. So 7 times x to the 0, right? So we think, well, x to the 0 we can cross out. So that's just going to leave us with 7. But here we have 7x to the 0. So you can even apply your power rule. So that's going to be 7 to the 0 and x to the 0. So we can cross them both out, which just leaves us with 1. So remember, when we cross everything out, we still have a 1. Okay? All right, here's some more examples where we put everything together. So here are all of our rules. So this would be a good page to print out if you want to practice. Okay, and we have our graphic organizer. So we're going to go through each of these rules. So we're going to do our power rule, any 0 or negative rules, product or quotient rules, and then if we have to repeat, we can repeat anything. Okay, so power rule. I don't see any power rule because that would be parentheses. So I can go through and do I have any 0 or negative rules? I do have a negative, right? So we're going to move this x to the negative 4th down to the bottom. So I'm going to rewrite here. 15 z to the 7th over 5 z to the 4th, x to the 4th, and then x to the 4th that I moved down. Okay, now I can do my product and quotient rules. So my product rules is combining these two. And my quotient rule, well, I have 15 divided by 5, right? So I can do that. It's going to be 3. And then z to the 7th over z to the 4th. I can subtract z to the 4th. So this is going to be 3 z to the 3rd over, and then I'm going to combine using product rule, x to the 4th and x to the 4th makes x to the 8th. So that is done. We've got one copy of each variable. We only have positive exponents, right? And everything is simplified as much as possible. All right. Another example here. So let's do our power rule. We have a lot of power rule to do. Okay. So my power rule would be 7 squared. So I'm using all those parentheses. So 7 squared, x to the 6th. And then anything, remember, anything to the 0 power, I can just cross that out. So I don't even really need to do much more, right? That was actually my 0 rule. So I can just leave that as is. So the only thing I need to do is simplify. So we're just going to simplify 7 squared is 49. We should know that one. X to the 6th. We're done. See, they're not always super difficult. All right, our last one here. So let's see. Do we have any power rule? No. Do we have 0 and negative rule? Yeah, a whole bunch. So let's do those. So I got some zeros. I'm going to cross that out. And then I'm going to move anything with a negative exponent down to the bottom of the fraction. So remember, cross the line, change the sign. So x is going to be x squared. Y to the negative 3 becomes y to the positive 3. And staying on the top of that fraction is z to the 5th. Well, do I have product or quotient rule? Do I have any of the same bases, or do I just have one copy of each variable? I do, and I've already moved my negative, so I only have positive exponents. So it looks like we're done here.